The universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Wow. Now, you know what? Welcome, everybody. This is Mark D'Antonio, Sky Tour Radio. And you can see right down below me here, you can see Tara. That's Tara. Tara's Cosmos. And over there on the left side up there, or the right side up there, is Amanda. But you don't get to see her. Daryl is taking the night off. And so we'll move forward. He'll be back next week, of course. But
He's
welcome.
in chat, though. Hi, Daryl.
What's that?
He is in chat, though. Hi, Daryl. Hi to everyone.
Daryl, I'm glad you're here. Yeah.
Too.
He's under the weather, folks. So, but that's good. I'm glad. He's very dedicated to everything, and he's an astronomer's astronomer. He's really, really good. And so I figure what we're going to do tonight is, well, make use of the fact that we're now a video show. For those of you that are listening on radio only, we are on StreamYard, and we are on Twitch and Periscope and Facebook and KGRA DB, the KGRA website. So we're all over the place now, live. And it is a show about astronomy. For those that haven't seen this before, Sky Tour Radio does reach for the stars. We're actually doing a science show, and it's a show that's within reach of everybody. And that's the way we keep it. And Amanda is a wonderful co-host. She's very effervescent, and I know she's just a face over there. Eventually we'll get her to turn her camera on, but it won't happen tonight because
a face and a voice. That's all you need.
Not
even the face.
No, but it's okay. It's okay. And Tara's always smiling down there. You can always see Tara smiling because she's a very happy-go-lucky person. But the reason Tara's joining us a lot now is because it turns out that she asked the most incredible questions that many of you are probably asking, but she thinks of them as well and puts them together, and then we go through them. It's turned out to be a very successful segment in Sky Tour Radio, so I hope you also enjoy it. Now tonight, we're going to talk a little bit about Mars, okay? And I just want you to understand that we've talked about Mars before, I know. But tonight we're going to be looking specifically at this location in the center of the screen. That's actually where the Perseverance rover has landed. And I might be able to generate a little bit of a surprise. If I can just get the video to play, I can actually play the actual video of the landing on Mars as relayed by the JPL people. But at the same time, they interspersed the video that was finally brought down from the rover, and it's really incredible to watch that because they didn't have the benefit of watching this video, but seeing what happened later was how they actually saw things, and they really did a good job, So what I'm going to do actually is to just run through that. I think that would probably be a cool thing to do. All right. So before we do that, though, I want to mention that we do have a planet to talk about in the Exoplanet Roundup tonight. And that planet happens to be around a star. This star is Gliese 486. It's an M-class dwarf. And Amanda, you know about M-class dwarfs, don't you?
A little.
Yeah, because what are the spectral classes that we have? The spectral classes are the colors of the stars. Generally, they go from a certain color to another certain color in the classification stream that we astronomers use. And what is that, Amanda?
It's been a while since I've done this, actually. I want to use the mnemonic of "Oh, be a fine guy, kiss me" by OBAFF. FGKM.
Exactly right.
And we're talking about an M dwarf right now?
We are. So is it a high or low temperature star?
Well, I mean, it's still pretty hot, but it's on the lowest scale.
That's
in
right.
this case.
Yes, he's good. You can't trip her up. Yes, the O stars at one end are the very hot blue stars, and blue is the hottest color in astronomy. And
think of a lighter.
Not.
Think of a lighter. That analogy, when you told me that analogy, because you think, fire is red, that's pretty hot. But if you actually light a lighter or something, the bottom where it's extremely hot is actually blue. And as it cools down, it's red, which is still hot, but
they can both hurt.
Oh, yeah.
Yeah. But to see, this particular star is an M dwarf, and there's a planet that's going around it, and this planet orbits the star every 1.5 days. That's amazing. It's actually a really fast orbiting planet. Compare that to Mercury in our solar system. Mercury takes 88 days to get around the sun. But the temperature on the surface of Mercury is hot enough to melt lead. It's really, really hot on the surface of Mercury, even though it's tens of millions of miles away from the sun. All right. But the sun is not a red dwarf star like this one. Okay. This star is a very, this star is actually a very cool star as stars go. So the habitable zone, that zone around the star where liquid water could exist, is actually very close to the star, but not quite as close as this planet. This planet actually is circulating well within the habitable zone for this star. And so if we were to look at the surface of this planet, it might look like this. Okay, this is exactly the type of thing. And in this image, you see molten rivers of lava. You can see a thick atmosphere. You see lots of volcanic eruptions going on. This is very likely what it would look like. All right. Now, keeping that in mind, why do we have any kind of interest in this planet? Because it's only 26 light years away, and it is very close to its star. It's, like I said, it's 2.5 million kilometers from the star, and it's about 1.3 times the the radius of the Earth, and about 2.8 times the mass of our planet. Now, what does all that mean? It means that if you were on this planet, the surface gravity would be 1.7 times the Earth gravity. So take your weight and multiply it by 1.7, and that tells you how much you'd weigh on this planet, right? Because the gravitational force is due to the mass of the planet and your distance from the center of the planet. So at the Earth's surface, you weigh a certain amount. Higher up, you'll weigh less, okay? And even farther up, you weigh less. All right. So basically, what happens is, if you were 180 pounds or 81.6 kilograms here on Earth, you'd weigh 306 pounds or 138.8 kilograms on Gliese 486b, this planet we're looking at right here. So it's not very hospitable for human life. In fact, nothing could live there on the surface because the temperature is 801 Fahrenheit on the surface, which is actually just a little bit cooler than Venus. So it's pretty warm there. But again, why do we care? Why do we care? Well, even though we know that there's no life as we know it that could live here, we care because of the fact that when we look at all the things that make up our technology and our ability to discern what's going on these distant exoplanets, we try to find planets where we can use them as a test bed. This planet is a super Earth, as we've called them in the past. And a super Earth is a planet that might actually have an atmosphere. So if it has an atmosphere, this is a perfect planet, being that it's only 26 light years away. Only. It took the light 26 years to get here. That's what a light year is, the distance that light travels in a year. And it took 26 of those years for light to get here. So that said, because it's so close, relatively speaking, it makes a good test site for us to see if we can discern what the atmosphere is made of, if it even has one. And that's something that makes this worthwhile to us. And I think that's a really cool prospect. So it means that this is an awesome planet for doing this testing. Now, I think that's kind of a thing that we're going to be talking about more of because we're going to be finding other planets that have the potential to have atmospheres. And when the James Webb Telescope goes up, whenever that's supposed to be, they keep saying that it's going to be, it's going to be this year. It's going to be this year. I'll believe it when I see it. Okay. And I know Daryl's with me on that. He said the same thing, before. He'll believe it when he sees it.
Yeah, but that's the kind of thing you do not want to rush and make a mistake on, because I'd rather be frustrated with waiting than frustrated when it all goes wrong. So
yeah,
it'll be worth the wait. From the way you guys are talking, I think it's definitely going to be worth the wait. So
yeah,
stay patient, guys.
Yeah. So the James Webb Telescope is going to be a telescope that will look at the universe in the light of the infrared, not in the light like we see with our eyes, but the light that's out past the red end of our spectrum in the infrared. And if you think about it, stars like Gliese 486, a lot of their light it's going to radiate a lot of infrared light too. So there'll be a lot of longer wavelength light as well. So creatures that are on a planet like that's around 486, not this particular planet like us, I think that one of the things that we'll find is that when a creature on a planet like this comes outside and opens their eyes, first of all, we'd be very surprised to see what their eyes look like, because they're probably not going to be the same as ours at all. Ours are tuned to seeing basically the color green kind of right in the middle, and then a little bit on either side to get us toward the red and toward the blue. But our eyes are somewhat limited. There are creatures, though, that might be able to see in the very high frequency wavelengths. That is to see wavelengths that are very, very short, that is high energy, that is blue, or very long, that is lower energy, or longer wavelengths, which is red. That's something that I suspect we might be able to expect. So it's kind of interesting. Plus, the other thing about a planet like this is that it's tidally locked. Just like the moon is always facing the Earth, this planet, it has one face. It's always facing that star as it goes around. And what's that give rise to? That gives rise to a superheated front side that's facing the star. And it gives rise to a terminator where there's a perpetual sunset all year round. All right? And then there's a perfect starry night sky viewing side. I mean, if you think about it from a real estate perspective, this would be pretty cool. It's like dream vacation to 486, well, not 46B, but let's say there's a C a little further out in the habitable zone. Okay, a dream vacation to 486C. We'll get to watch sunsets for your entire vacation because the sun never sets. It just sort of wobbles in the sky a little bit. You can take sunset photos all day and all night because there is no day or night unless you go to it. In the daytime, lay out on our beaches and enjoy sunlight 24 hours a day. You want to look at stars? Go to the dark side and enjoy starry skies. In fact, because it only takes 1.5 days for the planet to go around the star, well, that's a year in 1.5 days. Because remember, a year is defined as the time it takes to go around the sun. And in this particular planet's case, when it's looking at the night sky, you're going to actually see the stars moving, not because the planet's rotating, but because the planet is moving around the star. So you'll slowly see these stars sliding to one side all day and all night, forever and ever. And so you'll go through an entire year of the night sky in just a day and a half. And I'm telling you, I'm going to get in on this tourist industry. This is a really good thing. If we get to do this, I think that'd be pretty cool. I really
and just so people know, when you mention the Terminator, that's the line between the light and the dark, right?
That is correct. The Terminator is between the light and the dark. So, and if the planet's always facing the same side, okay, then there's going to be a line where the sun is always setting and the sun is always rising. and it's never going to change because you're going to be there, and the planet's not rotating because it's locked. So it rotates it rotates one time on its axis as it goes around the star. That's called tidal locking, just like the moon. When you say to someone, does the moon rotate on its axis? They'll say, no. No, that's wrong. It does rotate on its axis once a month. And that's why it's always got that side facing us, because it's rotating slowly. If you watch the moon from above, it'd be doing this over the course of a month. Just be spinning once. Okay? And that is the key. And that's the thing that I think is really interesting here. Now, I'd have to say, because of this planet's distance, it's going to give us a lot of really cool science. It really is. And that's going to be the neatest thing to see in the coming months and year. And when the James Webb, yeah.
I was about to say, as speaking of cool technology to come, Daryl might not be feeling well, but the trooper that he is, he's in chat, and he's wondering if you can comment on why the Webb has a gold mirror, hence infrared.
Well, the gold mirror on the Webb is it has to do with transmissivity and reflectivity, and it also has to do with deterioration issues. We don't want the mirror to deteriorate in deep space at all. But there's other reasons too, and that we can talk about those in a few minutes. But thanks, Daryl. He always likes to throw in the good questions.
Of course.
Yeah. But I tell you, we're gonna definitely have a interesting time, and like I said, we're gonna be talking about Mars tonight. Okay, so we're gonna be looking at that, and why Mars? And you say, well, we've talked about Mars already, haven't we? Well, yeah, we have, but we're gonna be talking about it from a different perspective. What I'd like to do, though, right now, is to just play a little video for you, and this video is the actual Perseverance rover descent and touchdown on Mars, as seen through the eyes of the rover cameras, but interspersed with the Jet Propulsion Laboratory personnel who didn't have the benefit of seeing this video that you're going to see now. They couldn't see it. All they saw were electronic indicators on their screen saying, okay, indication of jettison of the back shell or the heat shield, indication that the parachute was deployed, but they didn't know if it deployed correctly or not. Okay. Later on, several days later, all that video was actually downloaded. So let's watch, shall we? And watch the actual descent to Mars. If I can do it here. Let me get rid of this, though. There we go. All right.
Straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
Navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 480 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
So you can see what's happening now. It's still dangling from the parachute.
We have confirmation that the lander vision system has produced a valid solution in part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
You'll see one spot. You'll see a flash right around. There it is.
Current velocity is 83 meters per second at about 2.6 kilometers from.
Let me just pause it right there for a second. That flash you saw was when the parachute and the back shell, the thing that you see down below, look at the bottom of the screen, okay? You see at the bottom of the screen the parachute and the back shell in that right, basically the central little animation image. And then below that, or just to its right, you actually see the descent stage, it's called, all right, that actually has the lander attached to it, okay, the rover.
The surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN 50 Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Okay, what's happening there when they said terrain relative navigation? The jetpack, basically, that has the rover attached to it, is using this downward-looking imagery that it knows, plus a database of the site that it has on board, and it's deciding where exactly it's going to touch down. And it's going to do that to make sure that the lander, the rover, actually lands safely. Here we go.
We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
Now that is awesome.
Sky crane maneuver has started.
The thing in the upper left here, that's the sky crane. Down here is the rover descending. And this is the view from the rover looking down. And you see these are the wisps that are being raised by these jets up here on the sky crane. Now, you might say, wait, if those are jets, then how come I don't see flames? Well, the reason is because the fuel is hydrazine, and hydrazine doesn't burn with a flame. So there, now you know. And now let's land.
About 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
That's my favorite part, when they all start cheering with success.
I thought that was, see, to me, that's probably one of the best things I've seen in a long time. I absolutely love that. So now you got to see what they didn't see when Perseverance landed. But you saw what happened in addition. I thought that was a really beautiful landing. I probably watched it maybe, I watched Star Wars like 20 times when it first came out. It just went back in over and over and over. You know, my parents wondered where I was. And then here with this is Star Wars again. I'm watching it and going on and on and on. I've watched it probably 50 times. And find new things every time, by the way. Okay.
We actually do have another question from the chat, although we are coming up to a break soon. Okay. Our good friend Marianne Robb wants to know, did they have a specific spot they wanted to land, or did they just hope for a general area?
Yeah, they actually did have a very specific spot that they wanted to land, but they have what's called a landing ellipse. And the landing ellipse is a location that allows them to figure out where the rover will be roughly, and then they will actually make the rover, they'll try to get the lander to land in that spot as best they can. So to give you an idea of what we're talking about, let's bring up this screen right here. This is actually a interactive map that you can get to, and it shows Jezero Crater, which is this circular crater right here, right? And you see that little blip, that's the lander. This blue circle is the landing ellipse. This is where they wanted the rover to land. somewhere in here. But in fact, it actually landed right here. And if we zoom in even more, and this is beautiful, you guys got to try this. You can see that the rover has already been moving. Okay, this is Sol 16, meaning the 16th Earth Day on Mars. Isn't that something? Okay, and each day they took tons of pictures, and the pictures are available as well online. And I just want to point out something about why here, all right? And I know that we have a break that we have to go to, right? So that's something that we're gonna have to do. I think I might have to just go to the break first, but we'll do that, and then I'll come back and tell you guys what's going on here. But we will return in just a couple of minutes, right after this break.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now. The Paranormal Radio app, free in Google Play and the iOS App Store.
Are you still at it?
Yeah, I need more speed.
This baby's fast.
My dad's fast. He's scary fast.
You really think you could beat him?
Yeah, because I drink more tea than he does.
Yeah, right.
You know, pal, it's the tea that makes you go.
Oh. Hey, Dad.
You know, kiddo, you have to drink a lot more tea to be faster than me.
Drink the tea that makes you go. Life Change Tea. You may not need as much as Dad. You never know. GetTheTea.com. Log on to GetTheTea.com.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button, so just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
Mainstream media's most wanted. KGRAradio.com.
Hey, welcome back. On the break, I was trying to figure out what I wanted to show you. Hi, Tara. I see you down there. How are you? Okay. And Amanda's over there. I know she's there, but she's just in the darkness over there.
I have a page for radio.
That is so not true. Okay.
We have enough to look at tonight. Let's get back to what you were saying to Marianne.
We're just doing fine here. Okay,
right.
We're doing just fine. Now, what I was showing you guys before was this image. This is the Jezero crater where we watched Perseverance just land. And the terrain relative navigation is the system that just the jetpack basically rocketed the rover around to a spot that they thought was going to be safe to land. And that spot was this one right here. And they landed there, and it was, of course, properly safe. And now the jetpack itself took off, I think, in this direction and crashed. And the parachute and the back shell part are somewhere out here. I have a photo that shows all that, which I may not get to tonight, but and then the heat shield landed somewhere over here. So nothing impacted anywhere near this rover, so we're safe. But I wanted to point out something about why Jezero Crater. I think you can see it when we look here. If you notice, in Jezero, there's this structure, this blobby looking thing that's sticking out, but it comes on the heels of and just at the bottom of what used to be a rushing torrential water flow. This is basically a river delta that built up over time, and this river delta there was a lot of sediment that made this particular river delta, but the water's all gone now. However, before that river delta got laid down, another one was laid down. Look at this. Follow my cursor. Follow the bouncing cursor. You can see that there is another delta, another set of materials that were laid down, and we see it right here. Okay, this is also a raised area. All right. So all of this material in here also laid down by water. And you can see that some of the craters in here were probably filled by sediments when there was water here. Some are more recent, like this one. This crater happened later. You can tell because it's not filled in like this crater or this crater, so it's most likely younger. This one and this one and that one. But, okay, if you look, here's where Perseverance is. Perseverance is sitting on one of the earlier river deltas. So it comes as no surprise that when they looked at the imagery from Perseverance, that they saw what could be rocks that were deposited here by water flow. And that's something that some of you have noticed. You've talked about the rocks that have the holes in them. Okay. And if we get to that, we'll actually be able to explore that. But these rocks that have the water flow in them are really fascinating because they tell us a great deal about Mars. They tell us that maybe Mars was, or certainly was, a wetter place. And we know that it was at one point, but where did the water go? That's the question. Well, Mars also used to have a magnetic field. And that magnetic field was, for a time, protecting Mars from the ultraviolet radiation from the sun. You know, the sun would actually make this ultraviolet radiation would come in, strike the surface, okay? And, but because there was a magnetic field, the ultraviolet radiation was lessened to a huge extent. And so when water molecules, H2O, 2 hydrogens and 1 oxygen, actually was floating in the air, the ultraviolet light couldn't do any damage to it. But as the magnetic field waned, the ultraviolet radiation was stronger, getting through more and more. And it would strike the water molecules and break them apart. That's actually there's a name for that. It happens all the time in our atmosphere, in the upper atmosphere. It's called photodisassociation. Don't worry about the name. There won't be a test. Well, maybe. No, there won't be a test. And the photodisassociation issue was something that completely disrupts the molecule. And that molecule ends up having now only 2 hydrogens, which are lost to space, and the oxygen atom now heads down into the terrain, where it eagerly gets gobbled up by an iron-based compound, and thus makes a form of hematite, otherwise known as rust, really. Okay, and that is why Mars has this orangey red hue, because the entire planet's water, at the time, a vast quantity of water, ended up going into, from being disassociated by this ultraviolet radiation, went into the soils and ended up causing a rusty Mars to come about. And that's what it is. Mars rusted. Really neat stuff, and so I think that, keeping in mind that that when we talk about Mars, we're actually talking about, the planet next door. I think that's pretty cool, Now, I wanted to also show you that, we've had a love affair with this planet for a long time. Here is a actual image that shows us exactly where on Mars we have been. And these are a number of the missions to Mars that we're seeing right here. And I know Tara's Cosmos questions include some questions that relate to some of the things we've talked about and will talk about. But I want to just take us first through some of the locations and through some of the images for what we see on Mars, because Mars is a fascinating place. And there are many different places on Mars we've been, and it looks really cool and very different all at the same time. So let me start with the Phoenix Lander up here at the top left. Well, the Phoenix Lander was this beautiful lander which landed in the northern reaches up above Mars. And these northern reaches were actually near the North Polar Cap. So when we look at this location and we try to examine what the terrain looked like, right? Let me show you what it looked like. We get there, and this is not what we see, but this is. Okay, this is what we saw when we got there. From the Perseverance rover, we saw a very different landscape. We see boulders and everything everywhere, but this is a more subdued terrain. You basically see little rolling hills, little rolling hills. And these little rolling hills are typical for the northern wastes. Up there where the polar cap is further north, you'll notice that you can see that there's like pillows of soil here and there. That's because the Martian ices over the years have caused this area to have this sort of soft undulating appearance. All right, so it's very different. But there's something else that's really interesting about this location. First of all, this is the Mars Phoenix Lander. Okay, this was an earlier lander on Mars. It had these fold-out solar panels here. All right, and the Phoenix Lander had a little scoop on it, and that scoop kind of looked like this. Okay, so there's a scoop on the Phoenix Lander, and when it dug in the soil, all right, this is what it saw. All right, I'll bring it up. If you notice, it actually saw this white stuff. Now, what was that? This white stuff, they thought maybe was salt, or some type of salt in the northern.
Is it ice?
It is ice.
Ah,
Tara
awesome.
is correct. Yes, it's ice.
Look at that. What timing. First time we hear from her all night. And
I got it right.
Yay!
Yes, you did. Yeah, and it turns out if we look underneath the lander, and there's an image from under the lander, here you can see up top, up above, at the top of this image, you can see these little conical, looks like stainless steel. They're actually little engine bells that they were used to, the engine thrusters housing. They lowered this lander to Mars. And you'll notice that there are some flat white areas. Those flat white areas are areas where the thrusters blew the dust away. And it shows granite hard ice. So Mars has more ice than you can ever imagine, locked up hard as granite just below the surface. Look at that, huh? And that's up in the northern regions. It won't be that way down in the temperate and equatorial regions for sure. But that is a very fascinating development, isn't it?
It's amazing.
I think that's cool. So,
is that our future oxygen?
Well, actually, that's a really interesting question. But Perseverance is taking a different route. Perseverance is testing a theory to actually try and utilize the carbon dioxide in the Martian atmosphere as a source to make oxygen. And the reason is that there's an experiment on Perseverance called MOXIE, MOXIE, and I mentioned before that's Mars Oxygen In Situ Resource Explorer. And what it's going to do is take a couple of molecules of CO2, which is carbon dioxide, hence the O2, CO2, and it's going to bring them together, and through a chemical process, it will make a couple of molecules of carbon monoxide, CO, all right, and molecules, on the other hand, of O2 as well. Now, the experimental platform on Perseverance is only the size of a car battery, so it's not that big, okay? But if it works, then a higher efficiency, larger scale version is going to go and be brought there to make the oxygen for humans to breathe on Mars. If you think about it, what happens if we run out of oxygen? Well, we know the answer, but how do we breathe on Mars? We have to make our own oxygen. We can't bring it. I mean, we could bring giant tanks of oxygen. Let's say we have this massive ship and make these gigantic cigar tanks, and we perch them up in orbit and we start bringing oxygen down. That'll work. But at what cost? It's eventually going to run out. And if we don't get a resupply mission, that ain't good. So we're going to end up having to make our own oxygen. And the MOXIE experiment on Perseverance is just the thing. It's going to work. I promise.
Charles has a question from chat. He's wondering if you could give us a rough scale of the landing zone.
What's that mean, rough scale of the landing zone?
I guess where Perseverance left. Like what?
The size of it?
Like how? I don't know if he means like how much space did they have to work with to be considered a successful target landing, or I mean, I know it has the helicopter and it can move around some, but like the initial landing zone. I'm guessing, Charles, if you want to clarify that, please do.
Yeah, let's go back to this image for Charles. Thank you, Charles. That's an excellent question. Well, this is where Perseverance landed. Now, if we know anything about the previous Mars rovers, like Curiosity, which we'll talk about, Curiosity has been tooling around on Mars since 2012 when it landed. I mean, that rover doesn't get bored. I mean, it's tooling around and it doesn't stop. Now, just like Curiosity, Perseverance also is using what are called RTGs for power. What's that? Radioisotope thermoelectric generators. What's that? Well, little radioactive pellets that as they decay, they generate electricity through a process and heat that's needed to keep certain things warm on the rover. So Curiosity has enough fuel to keep going for quite a bit more time, and Perseverance has a similar RTG. Perseverance landed successfully with new wheels, by the way, that are better than Curiosity's. Curiosity has holes in its wheels, generated by the many boulders and rocks it's crawled over the years. And they think that the Perseverance wheels are a darn sight better. So when we look at this image here, there are limitations to what this rover can do and how far it can go. It can't climb cliffs, obviously. It can climb some hills, and they are certainly going to have it do that. Now, if we look at just some of the Perseverance imagery that I've had here, this is one image of one of the rocky outcrops. I looked at this one and I thought, the Perseverance rover, if that near side slope is just made to look more steep because because of the perspective we're looking at it, maybe the rover can go up the most nearest side of that and get up on top, if there's even a reason to do that. But this is an example of insurmountable terrain to the rover. If not, okay, then we have things like this. Boulder-strewn fields. Well, the rover can't just climb over boulders. It doesn't do bouldering like some, off-road vehicles here on Earth. Okay, it's going to have to avoid them. So it's not going to be able to go deeply into a boulder field unless it can get out, you know? So they got to be very careful about that. However, see the hills in the distance? Those hills in the distance could be a target eventually. Those hills are probably about 2 kilometers away, and they're going to potentially be a target. There are mesas, that is, the flat top hills, but the sides are pretty steep. The rover's not going to be able to go up those. And I don't know if Charles has clarified in the comments. I don't know if you have, Charles.
Yeah, I think he was actually looking for like a legend, which Daryl pointed out at the bottom left. I think he was looking like Belva Crater, for example.
Okay. Yeah, okay.
Not the picture you have up, but the screen share you're sharing with us. Where did you get that? Is there a link we could send to people in chat, or?
Yeah, this is, I will show you guys where this comes from. Why not? That's a good idea. So here's where this comes from. I will get rid of this image here for a moment, and then I will show you. All right, we're at this site here. This is, don't worry about that. But if you look up Perseverance raw images, okay, then you end up getting to a site that looks like this coming up. Okay. Here is the Perseverance raw image site. And you have, if you'll notice, 436 images so far. 8,436. So knock yourselves out. Have fun. And you can pick what you want. Do you want color process? Do you want raw? Let's say navigation front and, navigation cams and not the has cams. Okay. Now, all we're going to see are the navigation cam shots. And the navigation cams are up on the mast of the rover. Where is that? Well, I actually have a little model of the rover here that I can show you. And, okay, up here on top, we actually see, here's my little rover that I have. And these are the mast cams. We got cameras here, cameras there. We've got cams here. These are nav cams. These are nav cams right here. Okay. These are full color, high resolution imagers. Okay. This is called SuperCam. That's actually for yet something else that we'll talk about perhaps. But okay, this is the kind of thing that the rover has. It has this mast that it can rotate any which direction. Okay, and it can tilt, of course, any way we want. All right. This is, it looks down to see what's going on. Right. And then, of course, there's also cameras down here on the mechanical arm. This remote manipulator arm is actually very important to the entire situation with the rover, because many of the things the rover is going to do is going to be based on using this arm to acquire the data. Okay. So this is something that I believe is, like I said, will be a very important aspect of it. Okay. So these images that you're seeing, this is my model here, so that doesn't count. But as far as looking at the raw images again, you filter them the way you want. I'll just show you where the nav cams are. All right. And then you can actually go through and see them all. Like, for instance, what is this thing they're showing? This is called META. This is actually the Mars. This is actually a Mars weather station, and it folds out from that mast. Now, on my little machine here, let me just show you where it is. Where's META? META is right here. There's where META is. That's META right there, sticking out from the mast. Okay, so that's kind of a cool thing. You can actually see where things are, because sometimes you see photos, you don't know where you're looking, So this helps put it all into perspective. Okay, so going back, you could go here and you can download the images, and basically here we go. There's META. All right, and it's just a beautiful sequence of events when you look at these images. Now, I can tell you, when you look at other images, again, you can basically sift through them. In terms of the NavCam images, we can go through tons and tons of images here. Now, you'll see some are in black and white and some are in color. Well, they take pictures in color, but they also take pictures in black and white. And they will actually take some of the band passes and send them just those single band passes, like the red, green, and blue. They'll just send back some of those individual band passes, and then they can combine them to make an RGB image. Okay. I'm not sure if I think these cameras are color native on board. They actually take color pictures immediately, but they're beautiful. And here's Twin Peaks. This is a pair of hills as imaged by the rover. These are about 1.2 kilometers from the rover. But look at the littered area here in the foreground. It's probably not going to be easy for the rover to get over to those. It's going to have to find a way, maybe down this to the right side, and then pick a curious path to get up there, if it even goes. But what are they? These are hills that were dropped in here, maybe by water, that like pushing sediment along the way. Are they part of that lobate structure? Those lobes that we saw, like the river delta? Don't know. But it's really an interesting location. Actually, this color is kind of wrong. I can sort of modify that color here just real quickly. So that's more like what it is on Mars. Okay, it was looking too green, but you have to correct for the colors as well. So that's neat stuff, and that's kind of what we look for when we look at Mars. We actually think about doing all these things, making sure that we can see some amazing sights on Mars here. Let me just bring us back here. There we go. Thanks. I think it was Amanda who did that finally. Because I know that we're just getting used to the whole StreamYard thing, but I hope you guys appreciate how this is coming across, And I did want to mention and share with you something else, okay? We are talking about Mars, but I didn't go through the typical thing we say at the beginning, and I did want to just cover that. I wanted to, welcome you to our StreamYard production for the first time ever, and I also wanted to make sure you understood that we are an extension of SkyTour Livestream, which is your foray into the night sky with our wonderful telescopes that we use. We have our beautiful observatory scopes that we use, and we end up taking you on a journey into the night sky where you can see beautiful wonders of the night sky, and we process them for you, sometimes live, and then you end up getting to see the finished products, and those finished products will be made available to you. This scope pictured in the image here, this is the Connecticut-based scope. We have since taken this building down, taken down this telescope. We're building a new building that's bigger because we've expanded. And we're going to have another instrument in the building here. But out in Arizona, here is the new building in Arizona. And you might notice this door.
I was going to say, a very fancy door there.
That's a very fancy door. And I'd just like to have the artist who made this door come on and tell us a little bit more about it. Would you please, Tara?
Well, certainly, of course. I recognize that door.
I think you do.
Well, that is the Orion Nebula, the Great Orion Nebula that I got to see many times in your SkyTour live streams. And I was happy to create that image using bottle caps. And I estimate I hammered each bottle cap about 30 times, which includes flattening them and nailing them onto the door. And it was really fun. Took me about 100 hours to create that.
Is that amazing or what? And I think people need to understand too. These bottle caps are not painted. These are the natural colors of these bottle caps. And she used this natural color in order to create this piece of art. I mean, that's the part about art. You could just put any old bottle caps on and just paint your design. But she actually used the actual color of the bottle caps. Do you remember what the red ones were?
Oh, gosh, I've slept since then.
It's funny.
I don't remember.
Okay.
And yes, I did drink all of that beer. Yes, all of it. All of it.
Look
It
at
took
that.
about a week or two, you know.
Yeah. I guess the art project went sort of downhill after you drank enough beer to get, say, the blue part of the nebula. Those are, I'm assuming, Bud Lights.
Yes, it started as the Rose Nebula and ended up as the Orion Nebula.
That's funny. What was the yellows and the oranges?
Newcastle. Brown
Really?
ale. Newcastle were the yellows. Mm-hmm.
Wow. Yeah, actually, thanks, Rick and Donna Smith. No, actually, no one has ever guessed the correct number. Again, if you do, this is what you win. This is a actual 3D printed moon we make here. You can see that it's actually quite accurate. You can see most of the craters on the moon. And it is a piece of art. You know, they sell for a lot of money, but I'm going to make one for whoever guesses within 25 the actual number of the caps that would made up the door.
I think they can do it. I took the time to count them, so I think they can.
You did. You actually took the time to count them yourself because you had to apply them all.
Well, and afterwards I used a China marker and made sure I counted them correctly. And
did you really?
Yes, I counted each one and marked them, and then I polished them all off.
Wow. That's impressive. I didn't know that. Did you know that, Amanda? I don't think you knew that either.
I did not know that, but I do know a break's coming up. Did you know that?
Yeah, it's about time for that break right now, actually.
It is.
Yeah, I just didn't want to go to the break, but okay, we're going to do it.
We never want to go to break.
I know. Hey, folks, when we come back, there's a lot more to come. We got a lot more to show you.
And a special guest joining us.
That's correct, but I think people know who that special guest is, right?
No. Oh, besides Tara? Tara's always our special guest.
We have another special guest?
Surprise.
Oh.
But you'll have to stay tuned after the break to find out.
I guess I will too.
Okay.
All right.
See you on the
We'll
flip
be right
side.
back, folks.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now, the Paranormal Radio app. Free in Google Play and the iOS App Store.
Are you still at it?
Yeah, I need more speed.
This baby's fast.
My dad's fast. He's scary fast.
You really think you could beat him?
Yeah, because I drink more tea than he does.
Yeah, right.
You know, pal, it's the tea that makes you go.
Oh. Hey, Dad.
You know, kiddo, you have to drink a lot more tea to be faster than me.
Drink the tea that makes you go. Life Change Tea. You may not need as much as Dad. You never know. GetTheTea.com. Log on to GetTheTea.com.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button. So just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
Mainstream media's most wanted. KGRAradio.com.
was hesitating. I was thinking maybe I'd come back like this. What? But
it's a lovely song.
It is a lovely song. Yeah. That's
and look who we have.
And I see another name there. It's Daryl, or his Krypton name, Darrell.
Darrell. Hi, everybody.
Hi, Daryl.
Hi,
Darrell.
Sarah. Hi, Amanda. Hello, Mark.
Hi.
I'm glad
you're feeling well enough to join us.
I'll give it a try. We'll see.
All right.
Maybe I'll last an hour.
If anything happens, just, let us know ahead. Very good. I'm glad you're here, Daryl. Thank you for coming.
Thank you. I'm trying to figure out how to put my picture up.
Oh, there are little dots in the right-hand corner of your little thing, but it's okay. You're here. You're here. That's the important part. You were being so helpful in chat. I'm glad it, spurred some energy into you to get you on for the last hour. Great stuff.
While he's looking to get his camera up, let's continue with what I was talking about before to just sort of like take us to the other places. We talked about the Phoenix lander earlier, but you notice we have Viking, we have Pathfinder, we have Opportunity, we have ExoMars with Schiaparelli, and we have Mars 2020, which is Perseverance. Then we have Beagle 2, and we have Spirit, we have Insight, and Curiosity, and Viking 2. Down below, we have Russian missions, Mars 1, 2, and 3, the Mars Polar Lander, actually. I think Polar Lander, can't remember if that was ours. That might have been ours. But I think that's the one that failed because of metric imperial units mix-up. And that made the probe crash horrifyingly into the surface at high speed. Yes, don't mix your stuff up, But the Viking missions were really amazing. Viking was one of the most incredible early craft that we had. Okay, here's Viking. Project Viking consisted of 2 landers that landed in 1975 and 1976 on the opposite ends of Mars. Okay, if we take a look at that image again, you'll see. Okay, Viking 2 was over here, and Viking 1 was over there. That's the opposite side of Mars in this projection here. And when Viking 1 landed, and we saw this image, this was the very first image ever transmitted from the surface of Mars. And it was astonishing. We had the Mariner missions, which showed us Mars from up above, and other orbiters that had been visiting Mars, but this was the first surface shot of Mars. And as you can see, they got the colors just a little bit wrong, okay, because, the colors do look a little bit more muted than that. But, again, it's really quite nice. It's really a beautiful shot. I remember having this photo. I got a photograph of this, and I actually wrote to the USGS, who curate the data. And I had them send me an actual photo of the Viking photo here in color, and it was just beautiful. I cherished that thing because I just love seeing the surface of Mars. It was beautiful, And Project Viking led the way to other missions, And when we saw the terrain, we realized, wow, it's not going to be so easy to land here, If you look here, okay, you see that. Okay, Viking 1 was there, but then Pathfinder was a little bit to the south by a little bit, and it was over a little bit more. And the Pathfinder mission saw similar problems. Okay, glad there was no rover here, because it wouldn't really have made its way out. Oh, but wait, there was a rover. This particular rover that I'm talking about, of course, is Pathfinder. Had a little rover of its own, and it was called Sojourner. And Sojourner was a wonderful little rover that could. It was tiny. It looked like a toy. It really did. But it did some really interesting science, And to give you an example of the science it did, I'll show you right now. Let me see if I can show you that. Okay. Here is Sojourner right there, and it's by a rock that they called Yogi. The funny thing is, in the early days on Mars, they started naming all the rocks. It was kind of fun. But you can see Sojourner has one little solar panel on it. It had 6 wheels. And in this boulder-strewn field, it managed to come off of the lander, which is right back here, just out of shot, come down this little landing ramp, go around, turn a circle, and then go up to Yogi and start analyzing it. Really a very, very cool mission. And it was the first rover presence on Mars. And it was a very successful mission. Naturally, because all missions have a lifetime on Mars, the temperature on Mars can be well over 100 below zero at night. So you can imagine that it's kind of rough on the electronics. Why? Because the fluctuations can go as high as 25 degrees Fahrenheit during the day and then down to below 100 at night. So constant cycles up and down like that, constant up and down.
Speaking of days and nights on Mars, Ojo, I hope I'm pronouncing that right, wants to know, is there any photos of the sun taken from Mars? If so, where might we find them?
Of the what?
Photos of the sun taken from Mars.
Yes, actually, there are some. Actually, let me see if I've got any in here.
Would they be on that NASA.gov
Yes.
raw?
They would indeed. In fact, interesting thing I'll tell you guys right now, sunsets on Mars are not red like here. They're actually blue.
Wow.
And that's an oddball looking thing. There's a beautiful photograph of the sunsets on Mars taken by various craft, actually. And the atmosphere is a lot thinner than ours. It's a fraction, a tiny fraction of what ours, way less than 1% of what our atmosphere is. So at night, as the sun sets, Mars is a sphere, right? So as a spherical body, you know that in the spherical body, as the light is traveling to get to you from the sun, if it's coming from above, it goes through very thin atmosphere. It goes through thicker atmosphere when it has to travel long distances in the arc, along its distance from, say, the horizon to where the rover is. That distance is just enough to allow for Rayleigh scattering, which is a phenomena that occurs in our sky, which is why it's blue, and it allows for the air molecules to actually scatter some of the high energy light coming from the sun. So the air molecules will absorb all the light, but let most of it pass through basically, but scatter the blue light in every direction. Thus, we have a blue sky in our sky. On Mars, because the atmosphere is so thin, you don't see any effect of any of this unless you're looking through enough air. And because we're looking through enough air when it's at sunset, there's just enough to do Rayleigh scattering. At sunset, you'd see a blue sky as well here on Earth, except for the fact that we're getting most of that blue light is we have, of course, a very dense atmosphere, and all that blue light being scattered is overwhelmed, okay? And because we have a lot more light coming through that's not blue, all right, that is to say the red, orange, and yellow light that's coming from the sun, which we have on Mars too. But that light coming from the sun here through a dense atmosphere tends to scatter enough of the blue because it's so dense that the only remaining wavelengths that reach us are red, orange, and yellow. And thus we have red sunsets. On Mars, there's not even enough to even come close to allowing or scattering enough light to create anything but a blue sky at sunset. See, it's a matter of minimums. We have a minimum amount of molecules in the atmosphere of Mars. But there is a chance that we can terraform Mars at some point in the future. Amanda knows about this. We've talked about this a long time in the past, actually, several times, I believe. And I believe that the thing that's important is that if we talk about Mars as a planet, we say, well, it has an atmosphere. It has clouds. Okay. How do we know? Well, I can show you actually some of the clouds on Mars. This is, here is an example. This is an actual GIF file of the clouds, high altitude cirrus clouds moving at one of the rover sites, right? I believe this is Curiosity, actually. All right. These are drifting cirrus clouds at the Curiosity site. All right. This kind of thing does happen on Mars. And one of the things is that you'd say, well, wait, if there's an atmosphere, then can't we thicken it up? Yeah, maybe. But, it's not like the movie Total Recall with Arnold Schwarzenegger. The movie where he pulls that big thing out of his nose, like, yeah, out of my nose, get out. It's not that show, okay? But, in that movie, they also released an awful lot of oxygen after, pumping something into the core of Mars. It was fanciful, if not completely unrealistic. But another way to do this is to consider that Mars has had a magnetic field at one point. That magnetic field allowed Mars to have water vapor in the atmosphere. That water vapor in the atmosphere then was dense enough to allow standing water on the surface. The atmosphere was much denser. But as Mars lost its magnetic field, as it lost its magnetic field, it also began having ultraviolet radiation penetrate more atmosphere and get down to the ground eventually in high doses. And this sterilized the upper layers of the Martian soil, as well as I said before, ripping water molecules apart. The hydrogen got lost to space, the oxygen went down into the ground and bonded with all kinds of other materials in the ground, the iron compounds, and thus Mars rusted. But when we talk about terraforming Mars, one of the actual ways we can do it is by something that Amanda affectionately calls the Mars blanket.
I was waiting until you got to that.
Huh?
I was waiting until you got to that.
Okay, and you're right? I mean, we've talked about the blanket. Now, here's what happens. When you have a magnetic field, okay, a magnetosphere, the Earth has one, of course. Jupiter has one, all right? Other planets have semblances of them. The sun's solar energy strikes the magnetosphere, and it causes it to drape back behind the planet like a teardrop shape. Okay, so we actually have a teardrop-shaped magnetosphere. Curiously, as a side note, the moon flies through that teardrop shape once a month as it's going around the Earth. And that teardrop magnetosphere also has what are called hydrogen ions, just protons basically. And they hit the lunar soil and they interact, and they actually form water molecules that get trapped in the lunar soil. So the moon, it turns out, has a lot more water than we ever thought it did. Just a little aside there. Okay, which is good news for moon colonists, right? Now, as far as Mars goes, when we look at Mars, we say, well, wait, what could we do with Mars? If we create this object, this generator of a magnetic field that can sit, between Mars and the sun, maybe some distance from Mars at what's called a Lagrange point. Those are like parking spots in space. Whatever you put there, they'll kind of stay there because all the forces of gravity, they sum to zero at those points, okay? And if we do that, then what we might be able to do is have this magnetic field generator, and then the sun's energy will cause it to drape, just like ours drapes around, at times around the moon. But it'll drape around Mars. And that'll actually act like an artificial magnetic field for Mars. And then the water molecules can survive. They can still survive, and they will cause the atmosphere to get denser. We'll see more clouds. We'll eventually have running water on Mars. That is to say, standing water, like lakes and little rivers, perhaps. So there's a great
May I jump in for a moment?
Yeah.
Can you put back up that one image that showed all the lander locations?
Yeah.
Pretty please.
Yeah, I'm getting there. Yeah.
Hey, I have a question. Are all of those landers a first colony on Mars?
Well, I've often said, that Mars is the only planet in our solar system entirely populated by robots. And I've actually seen that repeated in the internet and on Facebook a number of times. I may not have thought of it, but I certainly thought of it originally as an original thought of my own, but I'm sure that other people have thought of it. So I guess there are robotic colonies, aren't they? They just don't talk to each other, Tara. Go ahead, Daryl. I'm sorry.
It's okay. I mentioned in chat a while ago, folks, if you look at this image where it says Mars 2020 and Beagle 2, that area, that is called Syrtis Major. The full screen image Mark also had up a minute ago also shows Syrtis Major. You might recall on SkyTour livestream when we looked at Mars back during opposition last October, this was the part of Mars we saw. There's Syrtis Major right there. You see how it looks sort of like an upside down and backwards Africa, where the southern tip is actually toward the upper part there. If you go back to that other image, Mark, no, the one before that with the
landing spots. Yeah,
landing spots. Well, okay, that there on the right where it says Beagle 2 and Mars 2020, that is Syrtis Major. And that is what we looked at during Mars opposition last October, if you might recall.
Yeah, that was beautiful.
Yes, and to the left of it, where it says Schiaparelli and Opportunity, that is Terra Meridiani, there where Opportunity is, and Sinus Sabaeus to the right of that, the whole thing making kind of a club shape there. To the left is Syrtis Major. That is what we saw last October during opposition.
We also saw the Hellas Basin here, too.
We did. The big white spot.
Yeah, the big white spot is just below Syrtis Major. And Mars is distant enough so that some ground-based telescopes can get some pretty good views of it. And there's a lot of people that have. Even the Hubble Space Telescope has actually taken some rather nice images of Mars as well. So it's amazing that the planet is the nearest one to us that has an atmosphere, and it's one of the hardest planets to get to. However, I mentioned before, as Daryl did also on one of the SkyTour radios, that the way we got to Mars was by using a special orbital transfer called the Hohmann transfer. That's Hohmann, Hohmann, I believe. And that looks like this. Okay, you can actually see the purple line, that's actually the probe. The blue dot, that's Earth. The green, of course, Mars. And you see how Earth is going faster than Mars. And it looks like that probe's going to miss Mars, but it's not. It actually gets there just at the right point. And of course, for us, it was 7 months later. Okay, and that's a transfer orbit. That's how they get to Mars. And that's why you see it was convenient for both China and the Arab Emirates to send a mission to Mars at the same time that we did. There's 3 nations in orbit around Mars right now. China's there, Arab Emirates, and of course, we're there as well.
Yeah.
That's a cool gift.
And the whole Hohmann transfer orbit, launch opportunities, the launch window happens about every 26 months, which is about the same as Earth's Mars opposition every 26 months. So they launch a little before opposition. If you watch Earth, when it gets closest to Mars, that is at opposition, right about there. And then a little bit after opposition is when Opportunity and the 2 other missions both arrived at Mars all at the same time.
Yep. Yeah, and so you see that's why it wasn't some kind of conspiracy or secret thing going on to anyone that might think so. It was actually the right time to launch to Mars for anyone that was going to do it. Otherwise, they were going to have to wait, a couple of years, and that wasn't that probably wasn't going to work, and it has to do with funding and where you put the monies and stuff. I don't know. But I do know that getting to Mars is not easy, but using the transfer orbit is the easiest way to get there. And I said this before, when you're heading to Mars, out of the front window of your craft, you never see Mars. Yet you know you're going to Mars, but Mars is always behind you and to the right until you get very close. Then Mars will sort of overtake and you'll start to get there. And then suddenly you'll have Mars kind of peeking in from the right side of your window. And then you'll be able to be calm and know that you actually made it. So, 6 and 9/10 of the months that you took to get there, you're going out of your mind thinking you're just going off into deep space, but then you get there and you say, Mars really is here.
Yep. And a Star Trek moment, I've said before, that's like when during the first Star Trek movie, when Spock had to time it right to hit the big opening and closing iris inside V'ger.
Yes.
Well, it's the same idea. You have to time it just so to get there at the right time.
That's right. Yeah, awesome, Daryl. See, I knew that even though you're under the weather, I knew you weren't going to stay away. I knew you couldn't stay away.
Yeah.
This is your home now. Come on.
You'll miss me when I'm gone.
Well, we miss you. Sometimes we always miss you when you're gone. So that said, I think that image here that we brought up before, I just want to bring up something real quick. And I know that some of these are going to stretch into next week. We're not going to get to every single site, okay? Because I do want to get to the Terra Cosmos segment, which is going to happen in just a few minutes. Right after our final break, we're going to start Terra's Cosmos. And as I said, I've never actually found anyone that has more questions in so short a time than she does. I'm impressed. I don't know why. I just think that I think that deserves airplay. That deserves someone to be out there because somebody else is thinking these questions for sure. Amanda asks all kinds of great questions. Tara has these pages of questions that she's put together. So maybe it's just that she's now got someone she can talk to that knows a little bit about astronomy. And so now she's just going crazy saying, I'm going to ask this, and this, but it's okay. I mean, but Tara, the 3 a.m. calls, they got to stop. Okay. I mean, I do have to sleep. You can't call me at 3, 4 a.m.
Oh, sorry. Ooh, my bad.
I'm kidding, of course. So, moving forward here, I do want to mention, we mentioned about Viking and Pathfinder. Somebody did that. Okay. But if we talk about, let's talk about this one here. This is the ExoMars mission. ExoMars was an interesting mission. I say was because the climate orbiter is still there. Okay. But it had this little, that's in the upper left you see here. But you'll notice there's a little detached lander underneath it. That is the Schiaparelli lander. It was supposed to land on Mars. And yes, I say was supposed to. But, sometimes things don't go right. Now, I don't know if it's because they did this mission in conjunction with the Russians, which they did, or not. But unfortunately, Russian technology, there are problems. They've just never been able to work some of these things out. They've made, I think, 25 attempts to get to Mars, and only 2 worked, and they were partial successes. We did 20 missions to Mars, and 18 worked. So I just think that when it comes to science, we should probably just share everything we know, because what the Russians didn't get might have been something we absolutely needed to know. So I just would like to see us all cooperate a little better. But the Schiaparelli lander, it literally shut off its retro rockets to land way sooner than it should have. And it ended up being, I believe it was several hundred meters above the surface when it basically thought it had landed. And the result was this. Okay, here's Schiaparelli as recovered by one of the orbiters. Here's the impact. You can see it splattered this way. You see some white objects that blew off the lander when it struck. Really unfortunate because there was some good science to be had there. You'll also notice this long, thin line. Now, I wasn't sure if that was something related to the actual lander or not, but I don't think it was. I think this is something else. And I'm going to give Amanda and Tara and Daryl an opportunity. Let's start with you, Amanda. What might have caused that? Do you know?
The heat from the rockets landing it.
Well, it crashed. It had already turned its rockets off, but that's a good guess.
Well, not to steady it to give it a soft landing in an attempt, even though it crashed. I mean, the attempt would have still been made now.
Well, but it was 700 meters off the surface when it turned off its engines. It really should have kept them all the way down.
Yeah. Okay.
Yeah. Tara, what do you got? What do you think?
Is it part of the rope from the parachute or something?
A good thought, but I believe this lander had jettisoned the parachute long ago, earlier, and was now going to just land with rockets, kind of like Pathfinder did.
So it didn't roll or anything to that final point and explode into flames or anything?
No. Daryl, what do you got?
Big bada boom.
The big bada boom. Yeah, that was a strike. But do you have an idea what that might be? I have an idea what it might be, and we're gonna have to go to break here in a moment. But my thought was, I think that's actually the scar of a dust devil that happened to be in that region of Mars, because Mars gets these dust devils, and they leave these real tiny streaks like this across Mars. They stir up this very light talcum powder, light orange material, and what's underneath is many times this darker material that hasn't had exposure to the ultraviolet light striking it from the sun, and thus doesn't have the same color change. They may be iron compounds, but not quite as rusted. So I think that might be a dust devil track.
That's cool.
Yeah, we'll find out. But you know what? We're going to find out more after we get back from this break. But this is Sky Tour Radio with Mark and Daryl and Amanda and Tara and Bob and Frank and Jimmy. And oh, gosh, it just doesn't end. We'll be right back.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now, the Paranormal Radio app, free in Google Play and the iOS App Store.
Are you still at it?
Yeah, I need more speed.
This baby's fast.
My dad's fast. He's scary fast.
You really think you could beat him?
Yeah, because I drink more tea than he does.
Yeah, right.
You know, pal, it's the tea that makes you go.
Oh. Hey, Dad.
You know, kiddo, you have to drink a lot more tea to be faster than me.
Drink the tea that makes you go. Life Change Tea. You may not need as much as Dad. You never know. GetTheT.com. Log on to GetTheT.com.
Welcome to the new KGRA digital broadcasting website, thekgradb.com. Here you'll find great new content, including the KGRA Classics, great shows from our archives. You'll be able to see the show times and information so you can see what show is currently on air. The on-air live button, so just go to this section and you'll be able to hear the show live with exceptional sound quality. We also have the Vault section. Make sure to subscribe to get access to great content and special features. We have the make content for our latest news and events, so make sure to sign up and you can be part of our forum. So make sure to check out the new KGRA digital broadcasting website, thekgradb.com. We look forward to seeing you there, and we hope that you enjoy the new website.
Mainstream media's most wanted. KGRAradio.com.
Well, hey, here we are. And welcome back to KGR8 Radio, Sky Tour Radio. I do want to take a moment to thank our extreme, I should say it that way, our extreme esteemed producer, Bill, for standing by and helping us as we converted over to a video format from the audio format only. So I want to thank you there, Bill. And I want to thank everybody else for listening. You guys out there, I hope you're having a good time. And before we continue on the Mars stuff, I just want to show you the beautiful Arizona sunset that occurred, that I took a photograph of. And for those that are interested in guessing the number of these bottle caps that are in the door that our own Tara on there had made, Tara did a good job. Okay. If you guess within 25 of the number, and then you can count them, they're visual. This image is reproduced on the SkyTour livestream Facebook site at full size. You can count each individual cap and even see the names on top of the caps. Okay, that's how high a resolution it is. If you do, and you guess within 25, the first person to do that will get this beautiful 3D printed moon that we create here in my company, FX Models. I think that's just going to be great.
1,326.
How many?
The same I always say, 1,326.
You're low.
Yeah, can you believe that? I mean, 1,000 would be a lot, you know? And I think I showed you guys before, but this is the observatory out there with the door on it that Tara has made. And inside will be this. This is the telescope system that is now waiting in storage. And on March 28th of this month, I'm flying out there, and I'm going to install all of this in here. And then we're going to go live with our remote site while I'm out there. Now, how's it going to work? Well, this, you might wonder what this is over here, these struts over here. This is actually called a roll-off roof observatory. So this is what it is, all right? Here's the roof, okay, that you see in the upper left, and it basically rolls off onto these support pillars, and that's what happens. Now, we're doing that all remotely, and I figured, hey, why don't we use these items that are made for this, that do this every day, and last 30 years, an ordinary garage door opener. And so an ordinary garage door opener takes the roof off, and it works beautifully. I remember when Tara was out there with Marianne Robb, they were actually going through and showing me, saying, hey, look, this is how it works. And they would push the button, and I'd see the roof come off, and push the button, it goes back on. All I have to do is wire into the button to do this electronically from 2,400 miles away until I'm a lot closer. So I believe that we're ready, and once we can start putting this stuff in there, it's going to be a beautiful, beautiful set of images that we show. And just, again, just a little bit to give you an idea of the kinds of things that we've taken pictures of. SkyTour Livestream East is under some relatively light polluted skies, but this is an actual photo of the dome here with the telescope systems. And you can see that the sky does have some Milky Way, but there's also a bright area. There's some light pollution in the distance. Well, that light pollution doesn't exist out in the Arizona desert, but it does exist here. But even so, look at the kinds of images that I've been able to take here with this telescope. This is the Rosette Nebula. It's a beautiful nebula that shows us a cluster in the center, this beautiful cluster in the center. And around that cluster is this gorgeous glowing hydrogen gas with dark knots of black dust that you see coursing throughout the nebula. It's beautiful. Then we have this one. This is the Dumbbell Nebula. This is a nebula that is basically it's a remnant of a dead star. When a star died, it actually puffed off its outer layers, and it became this gorgeous nebula we see. The blue color isn't hydrogen in this case. The blue color is actually oxygen, glowing oxygen, which I think is really fascinating. So, and when people see astronomical scenes like this, it makes them think of questions. It makes them think of stuff that they'd like to get answers to. And so, thus, a new segment we have called Tara's Cosmos was born. And it started when Tara, who was the artist who did this door, as you know, would just ask me questions offline. Oh, Eric, I had a question. What about this? What happens here? What about that? And I realized, she's not the only one that would like to hear these answers, I bet. I think there's a lot of people who would like to hear the questions and get the answers. So I want to welcome you again here, Tara. Thank you for joining us again.
I'm so happy to be here.
It is very nice to see you. I'd love to have you ask us some of your amazing questions. And those questions, now that Daryl's here, this is fantastic. The gang's all here. Okay. Between Daryl, myself, and Amanda, we'll do our best to answer your questions.
Awesome. I have a question for you about Mars still. I heard the recording of the wind.
Yes.
That was so cool. What are they learning from that?
Well, what's interesting is you might wonder why a simple breeze is anything to wonder about, right? But to this point, we hadn't understood whether the air currents on Mars are just sort of like large air columns that just move and are just sort of like non-variable. But we found with listening to this air quality on Mars, we found that, wow, Mars actually has gusts of wind. Now, it kind of hinted at that because we have these dust devils on Mars, and you can see them in some of the imagery, and you can actually see these dust devils spinning vortices that are moving around, and then they disappear. They're not tornadoes, but in fact, you could run through them here on Earth when they happen, and people say, "Ooh, wow," and they blow down canopies and things like that, but they don't pull roofs off houses. It's a very, very different, meteorological phenomena. That's a real tornado versus a dust devil. And so the dust devils on Mars are areas where there's going to be a concentration of high wind. But you learn a lot about the way Mars works by listening to the wind. And you can hear it's like, increases and decreases. What's causing those increases? What is it? Something is causing that. Where's that wind coming from? That gives hints to the global weather systems on Mars, which are really important to understand. Daryl, if you want to add, or Amanda, please feel free.
I have wondered, especially considering the dust devils, as you've mentioned, if Mars's atmosphere is basically only a few thousandths of a percent as dense as Earth's. Say when we heard the wind from Perseverance, how fast was the wind blowing at the time? And
good question.
How, if you were standing by a dust devil, how much would you really feel on Mars as compared to standing on Earth? What's a 70-mile-an-hour wind like when the atmosphere is only 6,000ths as much as on Earth?
And I think the answer is that it might be almost imperceptible to you. You might notice a slight wind, kind of like we heard on the microphone. Maybe those winds were 70 miles an hour. I don't know. But I do know that the dust on the surface of Mars, let's just look at this shot again. This dust on the surface of Mars is a thin layer, a fine layer, talcum powder-like layer on Mars. And that talcum powder-like layer requires a lot of wind to lift it. So here, if this is a dust devil or an impacting object, right, that's more than enough to do that. But the fact is, we see those streaks at certain seasons on Mars, okay, because they're more prevalent because the atmosphere is heating. And dust devils are born of that heat, that rising heat. So is the rising heat on Mars causing the winds that we're hearing? Air is compressible and extendable. You can actually make it less dense and more dense, right? Unlike water, which basically we say is uncompressible. So if something causes a rise in the pressure, then it'll trickle down and slowly push out some more air and maybe cause a wind to form. Kind of like a thunderstorm will actually cause big downdrafts that you feel eventually from a thunderstorm. You feel the downdrafts before the storm actually gets to you because they're going out in all directions around the base of that cumulonimbus cloud, which is the thunderhead. So when that happens, certainly we don't have that on Mars, but we do have cells of air that will rise and fall based on their temperature, even if they're frigid.
Yeah. And you have to consider sometimes, I mean, the dust storms on Mars can be so bad that it will wipe out all detail we can see from Earth. It's a planet-wide dust storm. How does that translate in such a thin atmosphere? What kind of winds are they looking at, and what would they really feel like from an Earthling's point of view?
Well, from a study point of view, I believe, I had read where the actual winds required to lift this talcum powder like dust off of Mars had to be literally well over 100 miles an hour to actually lift that dust because it's so thin. There's so few molecules of air striking that talcum powder that it's like lead compared to these air molecules. But, that's actually a really good question. I won't pursue that. I do want to give Tara a chance to ask more questions, though, because, she's been waiting all this time.
I'm learning so much. This is just awesome. So.
Well, you're staying after school, I guess, right?
Yeah, I don't mind. Nothing else to do, COVID. So.
I see.
Okay, I heard about the God of Chaos asteroid. What is that? Or should we be afraid? I don't know much about it, but it sounds scary.
Ooh. Daryl, would you
chaos?
Daryl, you want to handle that one?
I know absolutely nothing.
Okay, good, because I don't either. I don't know what the God of Chaos asteroid is, but you know what? That's not going to stop me from finding the answer, because I would like to find out what the God of Chaos asteroid is. I can tell you this, though. I mean, as far as asteroids that we have to worry about, we have a list called the Sentry List. And that Sentry List is objects that could pose a threat to us, but they're objects that are on the list until we get their orbital elements refined. Now, God of Chaos is an asteroid that's supposed to come by the Earth, make a close pass. Why they call it God of Chaos, I don't know. Okay, that's what they call it. I don't know why they call it that. But it's actually, it's an asteroid that's like 3 football fields in length. Okay, so it's pretty big, right? I mean, it's pretty big, I guess. It's 900 feet long, right? And that could actually, cause problems had it strike the Earth, but it's not actually gonna strike us. And Daryl, I think that's Apophis.
Yeah, I see Bill said that.
A bunch of people in chat say that. I don't know if that means anything to you guys.
It does actually. It's funny, I can't. I'm not looking at the chat, but I think it is Apophis now that I'm thinking about it.
We're all going to die, is what they're saying.
Yeah, I don't think so.
Oh, that reassuring story he just told us. Scratch that. Now that we know it's Apophis.
Well,
what does that mean? Different?
It's a near-Earth asteroid, and it may strike Earth in the future, and we're all going to die. There. Interestingly, wasn't Apophis the name of the head bad guy in the movie Stargate? Wasn't that Apophis?
It might have been, yeah, but he's really the Egyptian god of chaos, which is where Tara's question comes from, the god of chaos.
Right.
When you guys say it might hit us in the future, in astronomy, the future can be like millions and millions of years.
That's correct.
Are we talking millions of years, or do we even know a timeline yet? Or is this just newly discovered? Or
okay, let me
give me a sec.
Let me just clarify. Okay, when Apophis was discovered in 2004, okay, they thought initially that it was going to hit the Earth in 2029. Okay, but then they realized that it'll be a close flyby in 2029, but it will not impact the Earth. Okay, so we're not talking about an asteroid that's going to impact the Earth. Keep in mind that we're talking about an asteroid that's about 900 feet, in length, basically. Let's say it's round 900 feet in diameter, right? Basically. That's a spitball compared to the Earth, and most likely, in all likelihood, it won't cause a mass extinction event like the Chicxulub impactor did, which killed the dinosaurs. That was many kilometers in diameter, right? So much of Apophis, if it was to strike, will burn up in the atmosphere, but there will be fragments that'll reach the ground. They will do damage. They'll do localized damage, and so forth. If it strikes in the oceans, it'll create potential tsunami waves of some kind. But I actually think that we're going to have plenty of foreknowledge about that, because although Apophis is probably on the Sentry list, it's not considered a dangerous impactor. It's going to be a close pass in 2029, but it's not going to hit the planet.
So stay on your toes.
Stay on your toes. Yeah, okay. I guess we should do that anyway, because there are impactors that are going to hit us that we don't know about.
Well, this makes me think of, I mentioned in the past, the village in Syria, Abu Huraira, I believe it's called.
Jordan. Is it Jordan?
It's northern Syria, very close to Turkey. Actually, it's very close to Göbekli Tepe in Turkey, where they found those earliest stone ruins with the scorpion and the, I forget what the other animal was on it. But yeah, Abu Huraira in Syria, it's now under Lake Assad, but they did a quick dig on it before the lake filled up.
Yeah.
And they found that something did an air burst over the town and basically vaporized everything. It hit like temperatures of 4,000 degrees Fahrenheit or something, and obliterated and vaporized everything and coated everything in molten glass.
Yeah.
And this supposedly ties into the Younger Dryas impact, which happened back about that time, like I think 13,000 years ago or something, 12,000 years. And they're saying now that resulted in the death of all the megafauna here in the North America, and destroyed the Clovis culture, the early Native Americans who created the beautiful Clovis spear points and all that stuff. I mean, this is the kind of thing to think about that we could be facing, and if not 2029, sometime down the road.
Yeah, that's true. And it's not if, it's when. So that's why Space Force in part was founded. It's supposed to help develop systems that can destroy incoming asteroids, or at least help divert them. And I think there's a lot of potential for doing that here, especially with technologies that are promoted by folks like Elon Musk or Richard Branson, Bezos, with some of the other privatized space arena folks. They're going to actually be the ones probably to develop the anti-asteroid things, and for them it'll be all about money, but for us it'll be all about life. We'll gain our life, and so now we have to worship the Bezos god or something. I don't know. But that'd be horrible, wouldn't it? Oh, God.
There was a group called Planetary Defense formed here in Colorado decades ago.
Yeah.
And ostensibly their purpose was to protect the Earth and such things. But in effect, what they were was a marching kazoo band. They performed in all the local parades.
Well, I think we've determined planetary defense is a real need.
Oh, yeah. Well, and hey, it all points out, we need to get off this rock. And I guess that's what Elon Musk is all about.
Yeah, that's right. So I think that you're absolutely right. So Terra, that is the god of chaos asteroid you're talking about. When I realized it was Apophis, it all is right there. I recognize. I don't know why I forgot that he was the Egyptian god of chaos. My mistake.
Well, thank you.
Sorry. So you go ahead, ask another question for us.
Okay, so God of Chaos, these terms. What is meant by the edge of space? What do we mean? What's the edge of space?
Well, thanks for tuning in, folks. No, I'm just kidding.
Do you have time? You have 2 minutes?
Yeah, it actually really comes down to what is the edge of space? The edge of space is a sort of a tenuous region where the atmosphere basically gives way to less molecules of air, basically. That edge of space has been routinely called 120,000 feet, 130,000 feet. There's so few air molecules up there that you might as well call that the edge of space. It's sort of where the atmosphere wanes off to so few molecules that you don't even want to call it the atmosphere anymore. Now they're just errant molecules of air that get in the way of things like the International Space Station. Because as the sun's energy strikes the Earth's atmosphere will swell and get bigger and get smaller. And that process causes the particles in the atmosphere to go farther away from the Earth and strike the space station as it's coming through their orbit. Bam, hits these molecules. Doesn't sound like there's going to be a lot of force there, right? But over time there is. And the space station will start to slow down, which translates to it falling down. So they have to boost the space station up every now and then. Okay, so if the sun's particularly active and the atmosphere is particularly turbulent, some of those molecules can get out there and cause this to happen sooner than later. So that's why even things in orbit, especially those that are in the low Earth orbit, LEO, okay, low Earth orbit, these objects need to be boosted from time to time because they will suffer drag, atmospheric drag from these impacts with little molecules. So that's what the edge of space is.
Can I jump in there? Tara, you're not talking about the edge of the universe, are you?
Well, I might be. Maybe that's a question for another time. Is that the cosmic microwave background, those edges of that image? Is that the edge of the universe's space?
That is a really big question, maybe for another time. But
yes.
Imagine you're an ant crawling on a basketball. Okay, you will never come to the edge of the basketball. And that analogy has often been applied to the universe. There is no edge to the universe. There is no outside to the universe. If you go as far as you can toward the cosmic microwave background, you'll still, wherever you wind up, see the edge, see the cosmic microwave background just as far away as it was from where you started, even if you're halfway across the universe.
I love that analogy.
It's called finite yet unbounded. There is no edge to the universe.
Right, Tara? That's good, eh?
It's mind-blowing.
Yeah.
We have to be careful about suggesting that the universe is a spherical construct too, because it seems that the universe is what we call flat, which is
don't get them started, Mark. Don't use that word in astronomy. What are you doing?
I'm telling you the truth, okay? The universe looks like it's flat.
Oh, God.
That doesn't mean it's not like a flat Earth, though. Okay? It means basically that if you go out from the Earth in any one direction, you won't eventually come back and hit the Earth. Okay? It's not going to be like that. The universe is boundless in that regard. There is no edge. There is no curvature to the local universe. And that's a difficult thing to understand, and it is something for another time. We could talk about topologies. If people really want to do it, we can get into it. But our current indications are that the universe is actually what we call flat. But don't think a piece of paper flat, okay? It's got a different definition. It's a little more complicated than that.
Danger, Will Robinson, danger.
I know. We got a couple minutes though, or no, we got 1 minute. No. Maybe less than a minute. Darn it all. I think that's true.
Time to go. Unfortunately,
yeah, we have 30 seconds. But I did want.
If you think the show flew by before, now that we have pictures and video, this is gonna be a fast 2 hours, folks. But thank you for joining us on our debut.
You
Yeah,
haven't
which is
seen
really cool.
anything yet.
And they
Right.
yeah, actually, they haven't because I haven't shown them anything yet. I've got so much to show you. It's just cool. But I want to thank Tara. I want to thank Daryl. Thank you for coming back, Daryl, coming on with us. And Amanda, thank you. And, of course, our incredible esteemed producer, Bill, for taking care of us and managing our stream. He's smiling right now, and he's kind of going, yeah, that's right. That's right. I'm bad, he's saying. You know,
No, he's waving his hand saying, let's go, let's go. He's got another show coming up. So.
Yes, I know. Okay.
Nah.
All right, guys. You have done it again. You have explored and enjoyed another 2 hours of SkyTour Radio. Thanks to all who are watching and listening. Don't forget, join SkyTour live stream and enjoy us on YouTube. And if you get a chance, go buy this book. It's called The Populated Universe by yours truly. It's on Amazon all over the world. You guys have a good night. And don't forget, when you go out, keep looking up.
Except while you're driving.
Good night, everybody.
Bye.
Say good night, Gracie.
Gracie.